Hey, what's going on, everybody? It's your boy, Algebra. Sorry I can't be there today, but I'm out with the Bulldogs trying to get this dub this weekend. So what we're going to be doing today, even without me being there, we're going to talk about synthetic division. Earlier this week, we did long division, which meant we took our divisor and put it on the outside, put our dividend, this huge polynomial, on the inside, and we worked through this process of matching up the first term with an x squared this time, distributing that x squared to not only the x in the front but also to the one in the back. So it ended up looking like this. And then we subtracted on the way down. This subtraction sign needed to be distributed here and there. And so what that's going to end up doing is, as we continue this process all the way down to the bottom of the problem, you bring down the next one, you match it up again, you distribute that to both parts, and it becomes a pretty good situation for us down the road. You subtract over and over and over again, you match them up over and over and over again. Eventually you got down to this piece where it was exactly the same, and our final quotient was here. That's cool. It's right. I don't have any problem with you doing long division every single problem, except for the fact that it's going to take you forever. In order to speed up the process, some really smart person a long time ago, they came up with this thing called synthetic division. It takes all the same information, tweaks the process just a little bit, which is going to allow you to speed up quite a bit faster. Same exact problem, we're going to do it using synthetic division now. First step in synthetic division is to take your first polynomial, break it apart so that all you have are the coefficients. That means 1, 3, 3, 1. Instead of using x plus 1, I'm going to use a negative 1. And so the question is, where does that negative 1 come from? It comes from the same place as that x plus 1 was. It's your dividend. It's what we're actually breaking it apart with. The difference between having x plus 1 and using the number negative 1 is that this is essentially what we have solved it for. This is the actual value of x that we want to use in this problem. The process starts by moving this 1 straight down. I end up with a negative 1. And then a 2. And then a negative 2. And a 1. With a negative 1. Finally 0. Notice this is the same polynomial as what you had before. 1. There was 2x, and there was x squared. Same exact result. Same exact remainder. But this process went a whole lot faster than that original. So here we are. What is the process that I really used? I'm going to outline that process for you before the next problem. I'll give you a couple minutes really quick. Make sure that you're all caught up. Pause the video if you need to. When you restart the video in a second, we're going to be doing this giant problem down here at the bottom. And I'm going to give you step-by-step directions on how the synthetic process works. Told y'all when I restarted the video it was just going to pop up. That's exactly what just happened. 3 directions, step by step. As you copy these down with the next couple examples, I'm going to go ahead and talk through them. In the synthetic division process, if you look back at that first problem, we took all of the coefficients. We took those coefficients and we just laid them out right in a line. Conveniently in that problem and in this next one that we're about to do, you had standard form, which meant the powers were descending, and there were none that were missing. This time again, we have standard form, no powers are missing, and so we're pretty much good to go. The first step is going to lead me to a place that looks like this. 1, 5, 10, 10, 5, 1. The second step says that I want to solve the divisor for the number inside the box. Here's my divisor. If I solve that for 0, if I'm talking about the x-intercepts like we always do, that means I want to use the number 2 this time. And that number 2 is going to help me figure out, do I have a remainder or not down here in the bottom right corner? If I have a remainder, that's going to mean one thing. If I don't have a remainder, that's even better. We'll talk about that tomorrow. Step 3 in the process says to add straight down. This 1 goes straight down. And multiply to the next column. So what am I going to be multiplying this time? I didn't tell you any of the process last time because I wanted you to watch the pattern. This time I'm taking the 1 and I'm multiplying it times our box number, 2, right here. And I'm going to add straight down, 7. Repeat. Send your box number again. 7 times 2, 14. Add straight down, 24. Multiply that again, 48. Add it down, 58. Multiply times 2 again, 116. Add it down, 121. And one last time, multiply it times 2, 242. Add it together, that makes 243. So what does this tell me? Well, the first thing it tells me is that the number 2 made this thing grow quite quickly. On a graph, this would actually be way up here at the 2,243, and that's something that we'll talk about tomorrow. But the remainder is not 0, and that doesn't mean that you did the problem wrong. It just means that you had a remainder. That remainder would have said 243 over x minus 2. This 121, it would have been 121. The 58 really says 58x. 24x squared. 7x to the third. And finally, the very beginning of the problem was 1x to the fourth power. This is your quotient. It's nothing special. It is what it is. We want to keep these same directions in mind when we go to the next problem. The coefficients are going to become the top row. We're not going to skip any powers, which is a little bit different. But then we're going to use that information to help us solve the actual problem. Here we go. Coefficients: 5, 6, 0, -11, 14. 3 is in a box. Now I know somebody in the crowd wants to know, why do you have this 0 here? Well, there's something missing. There was supposed to be an x squared term in between the x to the third and the regular linear term, but there's not. I can hold that place by putting in a 0. We need to have this placeholder, because if we don't, we're not going to be able to add properly. If you remember back to the long division process, sometimes you had to make sure that you had somewhere to add, even though you could have been dealing with a binomial that skipped a level. We have coefficients. We have a number inside the box. So we begin our process. Straight down. 5. Multiply to come back up. That's going to make 15. Add down. 21. Multiply to come up. 63. Add down. Multiply to come back up. 189. And this time, notice earlier, all the numbers that we had so far were positive. but this was a negative 11. I needed to bring that minus sign that was in front of it. It doesn't make it any different. You just need to make sure that you pay attention to what type of number you really have. 178. And then whatever you get from 3 times 178 is the next number. I believe that's going to be 534. I just turned my head to look at Erica, but she didn't answer me. 548 is your final remainder. That makes your final quotient for this problem really ugly. And I agree. It's not something I ever wanted to give you. Numbers didn't work out this time. Oh well. Get used to it. This is what you ended up with. Cool. I'm going to pause the video one more time, set you up with one more example problem, and then we're going to be moving on till next week. Homework this weekend is going to be in the book, page 326, number 5 through 35, multiples of 5. And again, after we do our final example, I'll write that one more time. Go ahead and pause the video, check with each other, make sure that you understand. I'm going to check with my wife to see if she needs help opening this jar of pasta sauce right now. So while you were gone, while I paused the video, thought about it, wanted to go ahead and make sure that you had a copy of your homework right now, and also tell you about your tests. So while you copy down this next problem, our final problem of the day, I want to let you know that I did finish grading your tests. You will get those back on Monday. But before I give them back to you, I'm going to give you an opportunity to earn some extra points. I'm going to call this a test remediation. It's not corrections. I'm not giving you your test back to look it through and figure out what you did wrong first. I'm giving you 15 problems, all or nothing. No partial credit on any of them. Either you get the right answer and you get the point for it, or you don't. Period. The reason why we're doing this is because it's going to take your test and it's going to change the point total that it's out of, making it effectively worth more in the long run, but making each one of those problems worth a little bit less inside of the test itself. So for some of y'all where the class average was 70 something, this is going to give you the ability to move your grade up quite a lot. I mean, we're talking about 15 points, so it could be 9–10% on some people's grades. But if you did a particularly great job, you know it's not going to move you very much. That's the way a curve really works. That is due Monday, period. It's due Monday. The rest of the period after we're done with this example, you have the opportunity to work on that, use your notes, use other people. You're not allowed to use any other teachers, though. So while Mr. Milligan's sitting there, no, you can't go and ask him to help you with your test remediation. But you can definitely go and ask Holly. She knows what's going on. You can definitely go and ask Elijah. He's good at it. You can go and ask Nura. You can go and ask Brett. Doesn't matter who you work with as long as they are not already graduated from high school. Having said that, I've got 1 minute left in this video, and we're going to do this entire synthetic division problem that quick. It looks like a monster, but because we know what we're doing, it's going to go really quickly. Start with your coefficients. 1, 5, -5, -45, and -36. Inside the box, I would have a -4. Straight down. Multiply to get back up. Add down. Multiply to get back up. Add down. Notice it got bigger this time, but that's okay. Multiply to get back up. And add down again. Multiply to get back up. The remainder is 0. Interesting thing about this process is maybe you could go again. Maybe you could change the number. What did you just identify? You just identified one of the zeros of this function. The answer for your quotient is x to the third plus x squared minus 9x minus 9. Final answer. Bonsoir.